Hello, good people. We are back. Man, we have been away for quite some time, but things happening here and there, and we have to sort them out. We're back to continue with this layout, and we are still on the savory area. Don't worry, only a few items are remaining. For example, we did so many things. Well, all these items that are on this preparation area, we are going to design them in form of cabinets. Okay, if it's a sink, it will have a cabinet. If it's a worktop, it will have a cabinet under there. Of course, this is a fridge, an under-counter fridge, and yeah, all this we are going to make them probably one table, one sink, and that's it, because there is nothing else unique. So we complete it with savory, we go to prep area, then we will come to the cooking island. Right now, today we are talking about the 5 container bain-marie with a tray slide. Yeah, we will talk about the hot pass, the heated overshelf later. Heated overshelf, it's not much. Right now, this is the bain-marie. It's a 5 container full 1/1 GN containers. 1, 2, 3, 4, 5. No. This is the tray slide. Remember, the tray slide is supposed to be on the side where the waiters or the waitresses are picking food from, not in the kitchen. You know, here this side is in the kitchen where the chef is serving from. You know, you can access the undershelf, and yeah. So this is onto the side of the sitting area, right? Okay, now this is one of many designs of a bain-marie. Our bain-marie, the well and the top is one, and it's a complete unit. Welding is done here, and there. All right, so you bend this alone, you cut and bend this side alone. Okay, now these dividers, they are not welded, they are just placed on top, so that should you feel like using a half GN container, a third, you can move them around and see how you arrange them. Right now, this sliding doors, the doors are sliding. Yeah, this is the handle. That is why you can see we don't have any handle, and it has a double folder. Right, same applies to this other side. Yeah, now let me slide this door all the way to the other side. Thank you. If you look at our bain-marie, the undershelf, right, the undershelf is not coming all the way to the front because of these sliding channels. I don't like this design of having sliding channels under there, but again, it's quite hectic to do sliding doors with top rails. Yeah, it will make this bain-marie a bit expensive, and buyers might not be willing to meet the price, so we do it like this, a little bit cheaper but very much working. The functionality of the bain-marie is not compromised. The only thing that I want to mention here is that the undershelf does not come all the way to the front because of cleaning. You see, when you have these channels and they are on the same level, almost on the same level as the undershelf, cleaning will be an issue. So, and of course, given that this is a bain-marie, and as you can see here, we have a hole for the drainage and a ball valve, which we are also going to design a bit later. There will always be water down here, so cleaning it, even that cleaning, that's why you need this about 100 to 50 millimeter gap, so that when you clean, the water can go to the floor and you wipe the floor. Right? You can also, if you want, on these channels punch some holes. Right, I wanted to mention those few things before we get right into it. The other thing is that this panel, as you can see, these are bolt and the rivet type nuts. You call them what? We call them inserts here. I don't know whether you guys use the same word. Yeah, so instead of welding a nut on the panel, you do inserts, the ones that you normally, you know, the rivet that have threads. Can I use that word? Yeah, because you want this panel to be removable, where you are going to put your conductors, your electrical cables and all that. You hide them here, and you want to be accessing them in case of any maintenance and repairs and all that. Yes, we have different types of elements. Some people prefer putting straight elements, others circular element at the center. You know, different designs of elements that you will take it up with your electrician. Electrician will sort you out as far as the element is concerned. Now on the other side, this side, there is nothing, so this panel is fixed. You tack weld down here, tack weld here, and tack weld on the four corners actually, right? The idea is to avoid much welding, especially showing up on the front or on the body of the Bain Marie. Now I don't think there is, and the legs are adjustable. These are adjustable legs. There is a channel under there for where you're going to weld your legs. Yep. Now I don't think there is anything else that we should be talking. The others, let's talk about them as we design it, right? So I'll go ahead and close this, save all, rebuild and save. Okay, now the size of the Bain Marie. The size of the Bain Marie is 1830 by 700. And when you had the truss slide is 350 at a height of 200, right? And it has rods. These are not rods, but these are tubes, stainless steel tubes, dia 20, okay? And some brackets here. We have a front panel. Yeah, you know, what I should mention here is it is very important you keep the internal size. The internal size, this should be 515 by 305, because a full GN container is 530 by 330. Is it so? Yes, by 330. Yeah, you want the GN to be sitting pretty well on top of the Bain Marie, so that it may not slide and sink in the water and your food gets into the water. So the GN container should be sitting pretty. Don't want to mess your food up. Now here is the Bain Marie, the removable cover, the bracket to hold the truss slide, the truss slides, as we have said, dia 20 tube, stainless steel tube, separators, as the size of the separator is 30 millimeter. Yes. I don't know, I will kind of pin this PDF right down there in the comments. Okay, so let us start with the well, the top well, and we go to Solidworks, file, new, part, click OK. So we go to the top plane, new sketch. At the top plane we go to center rectangle, and this the size will be 16 16 1645 by 515 that is okay. Sheet metal, base flange, and the Bain, the top is 1.5 millimeter thick, right? You need some strength there. The parameters, you keep them. The K factor 0.5. Auto relief, you do tier type, right? Click OK. Then we go to edge flange. Make an edge flange all around the Bain. You know, if you are cutting this thing with CNC machine, just do it. Don't do this part alone and this part alone and this part alone. Yeah, you will have an issue. You will have a very big issue when it comes to joining them. You know, there will be some radius, the gap will be very huge, and you see, your welding should be done not from the inside but from the outside, and you want a very small gap. Actually, the gap should be like 0.1 millimeter. The radius, the gap is 1 millimeter. You're trying much as you can to make sure that the gap is very small so that the welding might not penetrate, because again, polishing this corner is very hectic. So when the gap is so small, you just do the pickling paste, clean it, and that's it. No welding there, because when you put your welding machine here, the tool will touch this face and touch this face and leave marks, yeah, and it won't look neat. Right, now the other thing I should mention is the depth. The depth here is 200. You know, this is determined by the depth of the GN containers. Yeah, this Bain 200 depth is for a GN container with a depth of 150. You don't want the GN container touching the eating element. There should be some clearance between the bottom of the GN container and the eating element. Right, then 200 is ideal. Click OK. You're good. Now let us go again and do edge flange this side, and you need to be careful where you are choosing your edge flange. You know, if you choose this line, make sure all the others you are choosing from the same point. Okay, there, and finally here, put your radius again to 0.1. I will change that later. I will change the default to 0.1, and this is supposed to be 93 because you want to keep the size of it to be 700 by 1830. That is the ideal size. Now we go to closed corner, closed corner, and we are doing bat type. The gap there is 0.1 millimeter, and you choose this. It will choose everything, so clear it, choose this, go to here, choose this. You can choose two corners and mirror the other, then choose this side, corresponding one, or the matching face is this face there. Right click. You can select all of them, but again you can do two and mirror. Go to the right plane, mirror entities, feature, mirror, and the entities to mirror here is closed corner. Click OK. You have your corners. Now edge flange again, sheet metal, edge flange there, again, make sure the radius matches the others, that is 0.1, and the size is 50 millimeter. You know, keep material inside, and the length from the outer. Those are things that you can manipulate the way you want. Right click or click OK. There is something there which that edge flange, let us edit it, and you know, if you can see that gap, they will come to overlap somewhere. So this gap, let us make it 1 millimeter, that radius. Now one should be big. Yeah, you don't want the overlapping. 1 mil, 2 millimeter. Is it? No, this should be 1.1, and this gap should be 2 millimeter. Yes, see, they are not touching each other. That is why we were getting that error. I think that fixes it. Fixed. There is no error, as you can see. Right, and the gap is not that big, so you're welding, no issue there. Now finally we do an edge flange of 15 millimeter going to the inside. Choose outer. Let us make this 15 mil, radius 0.1 again, 0.1. Choose all the other edge flanges. Yeah, so you do edge flange there of 15 millimeter and you're good, right? So your top is almost ready. Now some people, like I was saying, prefer doing this part alone, then the well alone, then they come do the welding right here, which I don't like that design, but it is a bit economical as far as the material is concerned, but it adds you a lot of work. So go ahead and save it. You know how you have been saving them. I have a folder here known as Bain, and I will save this as BM top. Save. Now let me do the hole for the drainage. Normal, choose that face and do a new sketch. Circle. Make sure you punch this hole before you weld the nipple for the ball valve. Diameter 1 inch, drainage is okay. You can do 1.5 if you want, but I think 1 inch is okay. And from this corner, make it like 100, and from the front side, make it 50. Again, you don't want the ball valve to be far away such that somebody needs to bend and open the ball valve, insert their hand in there to do what? To open the ball valve. Yeah, you want it right near you. Extrude and cut, link to thickness. Yes, your hole is there, your hole is made. Yeah, so that is it. Save. Now let me mention something else here. Let me save this in a form of DXF folder. DXF file. Then we include bent lines. Just want to open it real quick. Yes, no, I don't need to go to AutoCAD. Well, when you are doing your nesting, okay, let me open this file with AutoCAD. PC, desktop. Let me go to desktop, projects, Solidworks, layout, VM, DXF. Yes, here you go. So what you are going to do is you take this and this, and should I copy? No, let me move also this, move, and we do a line here. So when you're there, we go. When you're doing the nesting, cut this part alone, cut this part alone, cut this part alone. It will be economical for your material. Yeah, so that once you bend this, and you bend this, now you can come up and you can come back and join and do your welding, right? Don't put this all the way it was into CNC cutting. You will waste a lot of material. Cut them alone. In fact, these you can get them from these two sides of the well and the top. They are pretty small. You can get them from offcuts if you have them, right? And you're sure going to get a lot of offcuts, from the top, from the undershelf, and everything else. All right, so part 1 is done. Let us go to part number 2. New part. Click OK, and this time around we are making the back panel, so we are going to go to the front plane, new sketch, center rectangle, and we do a back panel. The back panel should be 1830 minus 15, that should be 1815. 18, let us do 1813. Give them a 1 millimeter allowance by 710. Yes, sheet metal, base flange, and the size here, the panels, you can use 1.2. material thickness to be 1.2. The other factors remain the same. Now we will confirm that size. We will confirm that size. Actually, let us confirm now. Don't see why we should confirm it later, while we can confirm it. The length and how we are going to confirm is not direct editing, but evaluating from this 15 millimeter bend, from here all the way to this is 1798. It's not 1830. 1798. So we can change. Let me also confirm now that I'm here, let me confirm the size of the side panel. That to this is 668. Yes, that is 668. Okay, so let us go back to our second part. We edit this sketch and change this to 1796. 1 millimeter allowance. You don't want it to be very tight. Okay, now we do edge flange. Go back to sheet metal, edge flange here, edge flange here, radius 0.1, size blind, and condition is blind, 50 millimeter. Click OK. That edge flange is good. Edge flange again. If you watched the hot cupboard, it's more or less the same as the Bain Marie. The design is almost the same as a Bain Marie. Yeah, this is 25 millimeter. Going to inside 0.1. Right click. Then finally edge flange on this side. And this side. Again 0.1. I need to change that. I will change it. And this should be 20 mil. Right click. Okay. Now let us do the edge flanges on the top. Edge flange here, going inside. Go into this side. And 15 millimeter. 0.1. Now edge flange again. Edge flange. Edge flange. You can do one side, say the top, and mirror it, or you can go ahead and do all of them as edge flanges, even down there. That. No, like I keep telling you, Solidworks has so many options of doing things. You know, you can decide to do one and mirror the other, or you can decide to go all the way. Depends with your speed. Good. Click OK. Your back panel is good. Back panel is good. Now, if you want, you can assign material to the top and to the side. Actually, all these materials are stainless steel. Yeah, so if you want, assign your materials. Why am I saving S? Part number 2, BM back. I always have an issue back panel. Save it. Let us go to file. We create. No. Sorry. We go ahead and create the side panel. So you open new part, and this time around we go to the front right plane, new sketch, center rectangle, the origin, and the size here we saw it is 668 by 710. Height is the same. This is 710. Click OK. Sheet metal, base flange, thickness 1.2. Then we create an edge flange here. This edge flange, the size of it should be 65 millimeter. We will see whether it will be touching the well, the body of the well. Yes, that's good. Another edge flange here. And condition blind, 50 millimeter. Want it to be matching the back panel. Then an edge flange here, 15 millimeter. Not 15 but 25. Go in that side. blind 25mm, right click, then we have edge flange again, and this is 0.1, blind 20mm. That is where the side panel, the side cover panel will be resting on, right? And the reason why we were doing this as 65, you want to have some pretty enough space for your cabling, right? At the back there you have just one edge flange, 15mm is the size of the edge flange, blind 15mm. This will be sitting against the back panel. Okay, now we create edge flanges here, and 15mm, you can even do 10. This is always for the purposes of giving your panel some strength, okay, and that sharp edge and all that, and neatness. It is very important to have this edge flange here at the top and at the bottom. Yeah, let us do one, then we mirror the other. That's good. Then go to top plane, feature, mirror, and what you're mirroring there is the last edge flange. Click OK. Like I was telling you, we have so many options. See, whatever you have down there is what you have up there. And remember, this will be the inside of the bend marie. So cleaning, assuming that this bend was going to the inside, you will have a dead corner here. Cleaning this corner, issue, my friend, issue, big issue. And you know, you're supposed not to make lives of the chefs hard. Side panel, yeah, you are supposed also to consider the end user when you are doing your thing. Now, as usual, when I have a few parts, I start my assembly and continue designing the other parts as I continue with the assembly. That's how I don't have a lot of issues with a lot of too much editing. Okay, before we continue, right click this one and make it float. Okay, so that we may do some mating here, and the matings we are going to do is expand this, the front plane and this front plane. Click OK. Actually we are mating just the planes, the top plane and this top plane. Click OK. Right plane and the plane of the top. Click OK. Exit. Right click and make it fixed. Good. Now insert component again, and the component to insert here is back panel and side panel. Shift, side panel, back panel, side panel. Now let us do our mating. Met. The first met I'm going to do, and most of the time we normally start when we are doing our assembly, we assemble the panels, the side panel, the back panel, the undershelf, then the top is always the last part. So this part sits at the back of the back panel, and of course they are of the same height, so this top and this, they met. Now the reason why I decided to go it that way is because I wanted to mention that here is where you're going to do your tack weld, and down there you're doing your welding. You are not supposed to tack weld anywhere here, because if you tack weld that, it will show up at the back, right? And you know, the problem with stainless steel, when you polish it, you will have, the marks will be seen. It will be different from the part with the PVC. Yes, the top of the back and the side rests on the bottom of this face. Now this face touches which face? Touches this bend, that this edge, the 15mm edge. That's good. Then we go to the right plane, and we go to right plane of the back. I want to expand this, the right plane of the back. See, so it is centered at the center. Then what else? This and this met, they are supposed to be flashing. Yes, exactly. And yeah, so that is it. I think that met is enough, right? Sure. Yes, that is enough. And there is some clearance, you know, the side panel is not touching the well. There is some clearance, good clearance. Yes. Now, the reason why the back panel didn't come all the way to here is for you to have room for the cover panel, right? Good. I think that looks okay. We can save it as save all and save this as Bain 5 container, or even Bain Marie is enough. Save. Now I want to do the side cover panel. The side cover panel, let me evaluate this and get the size from here to here. That should be that normal distance 567, so we do 566. And where else should we evaluate? From here to bottom here. To that bottom is 661 by 661. I can do 658. So we go to new part. Okay, we go to the right plane, new sketch, center rectangle. We have said this should be 566, or even 565. You know, you don't want things tight. Actually, you don't do things tight. 658, 658, even 656. We'll see what kind of gap will be left there. That's good. Sheet metal, base flange. The side covers you can do 1mm, 1.2mm. Some of these things, it depends with what offcuts you have. Yeah, you don't need to take a full sheet of stainless steel and cut this part. If you have offcuts, 1mm is okay, 1.5, even 0.8 is okay, because there is no weight actually. It's just a cover. And you know, when you do the bending, you give it some nice strength. Edge flange on all the four sides. And the size of it, remember we have an edge flange of 25mm, and you want your your side cover to be flashing with the side with the side panel. So end condition 25, do it 23. That's okay. Then do another edge flange round 15, 10mm. this edge flange here. Again, these edge flanges, especially these, they are the size, one of the determining factor. Sorry, one of the determining factors for the edge flanges here is your bending tool. Okay, if you have a bending tool that can do 8mm, 6mm, 10mm, you're good, but it should not be that big. You know, you don't want to waste your material very much. Alright, go ahead and save it as part number 4, and this should be side BM side cover, BM side cover. For the removable one, I'm not going to punch the holes for the bolts because I want to mirror it. I intend to mirror it when I do the assembly. So you will remember that one of them you need to punch holes. The holes you can put them, if you are smart enough, when you're nesting, you do your holes there. Right, insert, and we insert in side cover. Side cover, we are mating. This face should flush with this face. That's okay. And the bottom and this, that will be good. Now we can go to the planes. And is it the front plane? Yeah, the front plane and the front plane of the side cover. Side cover, front plane. Let me expand it. Front plane of the side cover. Good. Or you can even do width. Let us see whether there is some clearance. Yes, see, they are not touching each other, but again, don't make the gap so big. Yeah, you just want it to have some breathing space. Up here, it is good. The side cover should not go under the top. Under there, removing it will be somewhat hectic. Yeah, we save that change. Now we want to do the channel that will be carrying the body and the legs. Right, new part. The new part, got top plane. Right click, OK. Center rectangle from the origin. Doing these things from the origin, they help while you are doing your 668. They help while you are doing the assembly, you know, and this should be 150. 150, that's good. Go to sheet metal, base flange, and this, because it will be carrying the weight of the Bain Marie, should be 1.5mm thick. That's okay. Then do an edge flange here of say 20mm, radius 0.1. I think that's good. Right click. I want to edit the sketch. Edit the sketch, normal. You need to cut it 45. Do a line there. Do another line here. Smart dimension. This, make sure you define it as 20. You don't want when you are trimming the size to adjust itself. It's a 45°. Same applies to this side. 45. Then trim this, and you trim the other side. Trim that. That's good. Exit. Wow. happened? What happened to my edge flange? Oh, it's good, right? Yeah, it is good. Don't want it. You don't want to leave it at 90. It will be sharp and it will look ugly. Now go to the front plane. Is it? No. Right plane. And you mirror entities. You mirror that edge flange. Mirror. What you're mirroring is that edge flange. Edge flange. Click OK. I didn't want to do this, then I start editing here and editing, or extruding and cutting. So we save this part number 4. Number 5, BM leg. Let us just call it leg channel. Leg channel. Save it. Go back to your assembly and insert your leg channel. Insert leg channel. Met. The top of it should be sitting on this, and it should be flashing the outside. Then we go to the planes. Is it the right plane? No. Clear. The front plane. Front plane and the front plane of the side cover. Side cover, front plane. Not side cover, but leg cover. Front plane. Yes. We did 668, so let us edit this. You don't want it protruding. Edit sketch. Make it 666. 666. Save this. In fact, you can yeah, feel like that is okay. Now let us collapse these few things here and there so that we are not getting confused in the process. We go to right plane and mirror components. And the first component we are going to mirror is the side plane, the side cover, and that one. What do we call it? Yes. See how Bain Marie is taking shape. Now we need to evaluate and get the size of the undershelf. From here to here, it's 1666 by 530. Remember, we are trying to get that gap there. So we go to File, New Part, click OK, and go to the top plane, New Sketch, Center Rectangle, Smart Dimension, 1664 by 530 minus 15, 515. Yes, 515. Sheet metal base flange. This should be 1.2 millimeter. We don't intend to store a lot of things there, and in any case, if you feel like they will be using it as storage, you can give them, you can do some backing, you can do some channels there for backing. Edge flange, this edge flange goes to this side and it's 15 millimeter high. 50. and condition 50, and this 0.1, right click, then an edge flange here of 15 millimeter, 0.1, and condition 15 millimeter, then edge flange again. Sheet metal is always fun to work with. It's not as complicated as modeling. Some things like gears, what did we do here? This should be 0.1, and the size of that edge flange should be 10 millimeter. This again you're doing because of cleanliness. Now you do your edge flanges on the 3 sides, going down like that, down and down, and that edge flange there, and condition should be 35-40. Let us do 40 mil. That's good. Then finally on those 3 sides you do a 15 mil edge flange going to the inside. Point one, and this blind 15 millimeter, and you're good. Your undershelf is good. In case of anything, we will get back to it and edit, save it as part number 6. BM and Undershelf. You told me shelf is written like that, or it has an F. Our language here, English. English is not our language. Just learned it from the Muzungu guy, but we appreciate it because you know, we can communicate to the world. Imagine a situation whereby Africa was not colonized. We are all of us talking our own languages, and now the world has become one global, one big community. How would we be communicating with each other? You know, I'm here speaking my very sophisticated language, Bantu language, trying to explain to a Muzungu guy that I hope you are following how we are making this, okay? And from there, we go to not that plane. I keep mixing these planes, right plane, and we expand that. Good. Yeah. So you guys that colonized us, you did us good, even though you... what am I saying? Why am I getting into politics, man? It happened, and it was nice. In fact, at times I feel like we chased you from our country early. You should have, you know, stayed for quite some time to do some development here and there. Yeah, that's it. Now we are going to do the front panel. Before we do the sliding panels, let us do the front panel, and we made it. New part, front panel, front plane. We are doing the front panel, and this is center rectangle. The size of it is 1666, just like the 1666, just like the undershelf. And this, we are going to give it a height of 110. Sheet metal base flange. This can be 1 millimeter, 1.2, 0.8, but this is a bit long, so 1.2 millimeter is good. edge flange here of 20 millimeter. 0.1. Now developers of Solidworks and these drafting cards, you can hear me. If you happen to come to my channel, and actually you should watch how your softwares are helping us. I want to pose a challenge to you and any other software developer out there. Is it possible for you to develop these things and make them, be accepting voice commands? Like, I can just tell it, I need a base flange here, I need an edge flange here. Yeah, instead of clicking everywhere, the world is changing. I don't know whether the world is changing, and with all the technology, we are doing what we call this is 20 at an angle of 30. At an angle of 30. I don't know whether it is changing, making us more lazy, or I don't know. See, don't want to be clicking everything, or my kids, when they make this perpendicular, make that face perpendicular to this, and it should go on the reverse side. Where are you? Yes, on that side. What is wrong with you? I want you to take that route, and the size of that should be 70. Yeah. If our forefathers were to wake up today and find these things, that how our world has changed, I think they would just die immediately. My grandpa jumping into a vehicle which is driverless, and you try to explain to him that the vehicle is driving itself. What kind of shock do you think will hit him? You will just die again immediately. 30. We are trying to give this front panel some little bit of design. Don't just put a plain piece of metal there and call it front. Give it some design, and your design should not be limited to this. You do your own design. Just make sure that the total height of this front panel is anything between 200 and 250. You don't want, when you're designing, this should be 0.1 and this should be 50. When you are designing the door, you don't want the door to be very big. Okay, side panel, edge flange there, and that edge flange is 20 millimeter, same as the one below there, 20. So please get us softwares that can take voice commands. I expect Solidworks 2020 or 2030, it should be one which can accept voice commands. Now I will save this as part number 7, I think. Part number 7, BM front panel. Let me evaluate, measure, get the total height. The total height of this from here to here, 255. 255 is good. 250, 200, 255, that is good. Now let me do one more part. New part, okay. And I will go to the right plane, sketch, send a rectangle. That's okay. Total height we have seen is 255, 255, and this we make it 22 sheet metal base flange. This also can be 1 millimeter, 1.5 or 1.2, depending. You see this at small U channel, a very small U channel that you can cut from whatever offcut you have, or if you have some channels that are remaining in your workshop. Some of these things are always there in the workshop. Yeah, depends with what kind of work you do. Like this 20 is big, make it even 15. You will see where it goes. I will save it as part number 7A, part number 7A, and call it BM front panel channel. Channel is double N. Save. Now there are so many things that I don't need here. I can close this, I can close this, I can close this, I can close the side cover, I can close the undershelf, and we left with the front panel and that other panel. Let me insert component. I insert these two, that and that. Now let me mate this to this. You are trying to avoid this front panel to have sharp edge which are irregular, because you don't want to do full welding on the front side. We'll see about that. I'm getting ahead of myself. Why? Let me go to advanced mate and do with this face and this face. Then this. You want the side panel to be, the front panel to be inside that U channel. Yeah, so when you do that, that's okay. Is there anything else I will be mirroring? No, let me mirror it from here. We collapse this and expand this front panel. Right plane? Nope. Oh, which panel is this? No, I want to expand front panel and go to the right plane, then linear component, mirror component, and the component to mirror is this one. That's nice. This front panel, you assemble it. It's a pre-assembly. It's a you assemble it, tack weld here and tack weld here. No welding here. Okay, so it will always look regular there. Now before I insert it to the Bain Marie, before I assemble it to the Bain Marie, let me first do the top rail for the what do we call it, for the sliding of the doors. Okay, sometimes my what do we call it, Solidworks gives me some problems. Find the speed. There is something that I installed here which is kind of slowing it down. I will take a look at it. This is the same size as the front panel, and it is 16.66 by, this should be 60 millimeter base flange, sheet metal base flange, 1 millimeter. Also this will depend with what you have. Edge flange, that and this, and you can keep also the radius as it is, as the default. There is no harm in that. go ahead and save it as part number 8. Should be part number 8. BM sliding channel, door sliding channel. Okay, then because there are two doors, there is an anchor line there in between that channel, same size, same length. No, I don't want to do corner rectangle, but center rectangle. The length is 16.6 by 30. Good. Sheet metal, base flange, same parameters. Then an edge flange here. .20. Save. I will save it as part number 8A. 8A. BM sliding angle. Is angle and angel? Is that angle written like that? Yes. So we go back to our assembly and insert those two. We insert sliding channel. I want to rotate it on, not on the y-axis but on the x-axis, for it to, you know, and insert again the part number 8A and rotate it like so. Now met. This angle line should be sitting inside this channel. That's good. And this and this should be same size. Then we can go ahead and do width. Advanced met the width between this and this and this face and this face. Great. Now you have two chambers, compartments, or whatever, for the purposes of having each door sliding on it. You know, this acts as the stopper for the first door, and this acts as stopper for the other door. Now we continue mating this met. That face should sit on this. Oh, are they good? Please select a met. Okay, standard met. Standard we go. Did we select standard coincident? Good. And the bottom of this channel, they should not protrude under. They should not be visible. That's the thing. And why I decided to mate them before putting them before mating with the Bain is because I didn't want issues with when choosing the faces. Yeah, we'll start hiding components and all that. That's good. Then the whole thing, now you see how it goes. Now the whole thing, this should be sitting, should be flashing with this bottom. Don't put it in there, don't let it go all the way up there. And this should flash with the front panel. That's good. Now you can go and pick the planes, the right planes. Is it the front? No. Oh, I'm getting it wrong every time. Right plane of that, and right plane of the front panel. Is this the front panel? Right plane. What happened? No. Clear selection. It should be note of that. I think is the front panel angle. Yeah, that right plane. This right plane? And which right plane? And this right plane. Yes, exactly. That mat is good. See? That mat is good. Now the other thing is, let us insert again this channel and the angle for the bottom part. One. This we are not rotating. Met them just like we mated the others. This sits on top of this. It flashes with this, and you go for advanced with this and this, then this face and this face. That's okay. Then go back to standard and coincident relationship. Try to make this face with this face. You see, where did it go? You see, then this sits on top of this channel. Now you realize this channel was a little bit long. In fact, you can make this to touch this face. Yes. Now, if we were to make this flush with the outside, then the doors would be inclined. They wouldn't be perpendicular. They wouldn't be standing at a right, angle to the ground. They wouldn't be straight, and it wouldn't look good. So what happens here between this space here? There is there is a small front channel that compensates that distance of 21. And how does it look like? Only one way to find out, and that is by creating it. So I've opened a part. I'll go for the let me go for the front plane, sketch, center rectangle, same size as the other one, as the undershelf, everything. That should be 1666. Height of it should be right around 1 inch, that is 25 mil, and you call it base flange. Give it base flange. Again, thickness is not that important, determined by, and you saw that distance there was about 21, so we can make this 18. We are giving it some painting allowance. You don't want it to be bigger than 21. Actually, if possible, should be less than. So here we do 18 mil. I click. Then here we have an edge flange going down, and that down should be like 10 mil. Same radius, 0.1. That's good. And again here we have an edge flange of 15 mil. .1, and this is 15 mil. Good. So that takes care of that space that you saw hit, and your Bain will be very good. BM, we are saving it as BM front lower what? You can call it channel. As long as you know what you're doing and the namings, I don't think that you're going to have any issues. Let us close some of the things that we don't need. We don't need this, we don't need this. This is done with, this is done with. And also once we insert that part that we've just created, we'll close it. Met. So now this flashes with the front. That's good. The bottom side of it, where is it now? The bottom side of it touches the channel. That's good. And you can have, yeah, there's something there we need to, like that. Let me see. This is good. This is good. You need that bend. You don't need this gap here. You don't need it. Well, you can leave it like that, but you ideally don't need it. So we can make it 21. We can edit this and make that edge flange 21. This. No. I don't want to edit the sketch. I want to edit the flange there and make it, that was 18. Can make it 21. We save it and even close it. Okay, close it. Yes. But again, you be very careful, let it not clash with the channel. So your Bain is looking pretty good, and you have the gap, the one I was talking about for cleaning. I was talking about this channel, this leg channel being big, 150. You see it is carrying all this. It is carrying the undershelf, it is carrying these channels, and it is also carrying the side panel. Okay, that is why you saw has designed it that big. Okay, now let us do the doors. The doors, we evaluate and see what size of door we want, and we are talking about from here to the top of the other channel. And for your information, that should be 422. Now let me mention something real quick here. The top channel, this top channel, make them this edge flange. You see, we have made it 20 millimeter. You can make it 30 or 40. Reason, these doors should be removable, right? There should, the size of the door should not be touching exactly like the way we have measured 422. It should be, there should be at least 20 millimeter, so that when you lift it like this 20 millimeter here is covered, you can remove your door. I hope you got the concept. All right, yeah, so let us make the door. And this height of the door we have seen is front plane, sketch, center rectangle, height of the door. Let us make it at 425, 400. But if I make it 400, remember, or 405, let me make it 405 by 800. 800, 1600, 1660. We need 1600, 1660. 1660 is the size of the undershelf. 800, that should be 1600. There will be a gap of around 6 millimeter, so we make it 850 or 825. 825. You want a nice overlap. Okay, we will see. You know, we normally go back and edit should we encounter some difficulties. Yes, that's good. Edge flange round 1, 2, 3, 4. Default no 0.1. Size of that should be 20. Right click, you're good. Then do edge flange on 3 sides of 15 millimeter. There is no need of making this door double skin. This edge flange should be enough. Don't need to put a cover there and do double skin. No double skin is where you might need to do some insulation in case it's an old cupboard and you don't want to lose any heat. Now here we do an edge flange going this side, and that should be that 30 mil is ideal. 30 mil, your hand, your fingers can fit in there really well and open the door. Yeah. Now another thing I can mention is that you can also do some different design, in that you can make this at an angle. That depends with what you want. This is just a basic design of a door which you can play around with. Be creative, man. Don't do it the way the others have been doing it, right? Your handle is good. Now we need to do a hem here, and it's a double fold. Sometimes back I used to wonder, why doesn't the double fold go like that, go to this other side? Yeah, and I realized if it goes like that, the door won't be closing well, so it should go in here. This cannot pose any hazard to the user. Okay, that's what you hold and you push your door. Save it as part number 10. Part number 10, BM slide in door. We will, when we are doing the assembly, we will insert the other one and rotate. You see, you can't mirror this. Insert, no, it's not met. It's supposed to be insert. Insert component, sliding door. That's good. Let us make this met now. We'll only give it 2 mets. Coincident that should sit. Let us do it with the inside. Let that side be for the inside one. Then we go to advanced met width, and we'll take it to be between this face and this face. You still have space, and this and this. That's good. We don't need to, we want some movement. We don't need to make it, you know, fixed, because that is how it is supposed to be sliding. Now if you can see, that door is perpendicular and it is inside. Can we change this to transparency? What else should we do? Transparent. This also, let us make it transparent. Is there anything else that needs some transparent view? Let us make this also transparent. I want us to see how the door is behaving. Now let me open the door and give it some color for the purposes of seeing. Parent. We go to appearance. Can I make it red? Yes, just for the purposes of seeing it. You see, it is within the top channel, so that there won't be, cannot fall to this side or tilt to the front, right? And as I was saying, you need, okay, it is slightly shorter than just 5mm going up. Yeah, 5mm is okay, because when you are inserting it, you need to lift it. It's only that we locked it down there in the mates, but you lift it, there should be some clearance here in that rail, in that channel. You lift it, and then you get your clearance down here, and you remove. Don't make it permanent, okay? Do not make it permanent. Now we can collapse. And change the transparency again. What material is transparent? What part is transparent here? The top? We change transparent. The front panel? We change the transparency. There was something else, the channels down here. That's good. Now we insert again, sliding door, and we want to rotate it on the z-axis. Yes, like that. Then we can do our mating, and we mate that bottom sits, that face. What's going on? Delete. No, actually clear selection. What happened? This face shouldn't have rotated to this face. Yeah. And then we do advanced, and we do our weight. Our weight is from between this face and which face and this face here. I hope we are going to see it. I hope we are going to see that channel. Where is that face? Yes. And this face. And that face. And this face. I hope the mat is good. Let us slide the door back to its place, and this other one to its place. How is the overlap? Again, you don't want a big overlap. When the doors are closed, you don't want a very big overlap. How is the overlap? this overlap is good. So your Bain Marie is kinda done, right? Go ahead and save. Yes. Now we go to part and create the legs, and the legs are of dia 50mm. Part top plane, top plane, sketch, circular hollow section, dia 50. And since it is circular hollow, let us offset by 1.5 and should be on the reverse direction. Click OK, go to feature, extrude, and the height of this should, I think, be 120, 110, 120. Ideally, the total height of the Bain Marie plus the Grommet should be 860 BM leg, CHS leg. Yes, that's good. Save. Now we create the tray slide. The tray slide part should be like this. We go to the front plane, no, right plane. Don't want to do a lot of editing. Can we do this 200? And this is 350. Sorry. This should be 350. 350. What did we do? This should be 200. That's nice. Then something that we didn't do, that we make them construction. Yes. Now line, that is the profile. Good. And we make this one is 35mm and the other one is 35mm. And we go to sheet metal base flange. Yes, and this should be 1.5. Right click, good. Now we need edge flanges. Edge flange here, edge flange here. Do we need edge? No, we don't need edge flange there. We need edge flange here. The size of that edge flange is 35mm, and this should be just 0.1. You can leave it if you want. It's no much. Yeah, so let us create edge flanges here and here and here. That edge flange should be 15mm. That's okay. Now, since this part one can hurt themselves as they are touching, we do some double fold here on the lower one, and then we select this face, create new sketch, normal. You want your sliding, what do we call them, sliding tubes to be sinking the half diameter. Make them equal, and the size of it should be 20mm, 21, 20.5, 20.5. Again, you don't want it to be very tight. yeah, and the spacing is 60. The spacing from one tube to the next should be 60. How many did we do? 1, 2, 3, 4. They should be 5. $60. You can do one and linear component and do some, what do we call it? Is it hurry? This and this should be equal. You can hurry them, yeah. In AutoCAD we call it hurry. In Solidworks it's pattern. With that done, extrude and cut. Feature, extrude and cut. Extrude and cut. Somebody can hear like I'm saying extrude and cut. It is extruded cut through all. Nowadays my Solidworks is crashing. I think I need to upgrade to use Solidworks 2022. Save it as part number 11, 12, and call it BM sliding. Does it have a name? Sliding tray bracket. And you can call it left side, right? Then we go back to the Bain and insert component, sliding tray, that. Then we met. No, let us insert also the leg. Good. Insert also Grommet. Insert Grommet. Browse. The Grommet was in my pre-tutorial. Grommet. Yes. Now met. Concentric, that and that. The Grommet goes inside, and coincident relationship. This face to that. That's okay. Did I exit there? Let me met again. I shouldn't have completed the met, and I should go for the leg. Is it right? Yes, that right plane. Then I go to leg channel, right plane. Yes. No, actually. Leg channel. No, it is the right plane of the leg channel. Right plane of the leg channel with the leg right plane. Yes, that's good. Then I can take a distance and make it 15 from here to here. It should go inside. That's good. Then coincident, this face to leg is in its place. We will edit that and take it a little bit inside, make it 50, make it go inside at 25 or 20. Let us mate again this to this, to the back, then this face to this face, to under here, click OK. Then you need it going inside by say 50, this and this. That's good. Yeah, now collapse this and collapse this, then open mate. We edit this distance of the leg, we edit it from 15 to 25 mil. Let me see, the 25 is ideal, 25 is not ideal. We don't want it going inside very much. 50 is good, 50 is good, that's good. Now let us mirror components. We mirror that leg, and we will mirror it on the right plane. Mirror components. Component to mirror is the leg and the grommet. Right click. Then we go back again to the front plane and the mirror components. The component to mirror is that last mirror. Good. Now we open this and do a few more changes here and there. We save this as save as a copy and open, and this should be number 12B, and we call this one right bracket. Then we will choose this edge flange and edit it and change the direction. It's only the direction that we are interested in changing. Yes, the size remains the same as 30. The others will reset themselves automatically. Yes. Now extrude and cut, we need to delete it and do it again, and also delete that sketch. Yeah, the reason why we are deleting it is because the orientation where we had done the sketching, it was on the other side, so extruding and cutting it will cut on the wrong side, or well, that's it. That all these circles, we choose them and make them equal, then we smart dimension them. We've already made them equal. Oh, this should be 20.5, and the distances should be between this and this should be 60. This and this should also be 60. This and this should be 60. And the other one finally should be 60. That's by now 60. That's what we are talking about. Then extrude and cut through hole. Extrude and cut through hole. That's the end condition. Then save. And insert it on the Bain Marie. First save this work. You know, my Solidworks is misbehaving. It's totally misbehaving. Insert, and we want the right one. Yes. Now we met these flashes with this. And they are the same size, so sorry, I didn't mean to choose the hedge. It is this and this, they are flashing. Then we go to distance 50. This and this should be 50. Yes. Now let us determine we need like 3 of them, 4. So let us determine between the distance between the 3 is 1693, and we need how many? We need to do 4. I want to linear component this 1693 divided by 4, that should be 1693 divided by 4, that should be 424. I'm not sure. We will see. So we go to this and the linear component. We are linearing them in that direction, and we have said let us go for 50. We play around with it. We need 3 of them, and the component is this. Right click. Now what is this distance? Evaluate measure from here to here. No, let me clear this selection. From here to here is 731. Then from here to here to this side is 415. Let us get the difference. 731 minus 415 divided by 4. The spacings, we have 4 spacings, right? 1, 2, 3. Are we supposed to divide by 3 or by 4? Times 4 divided by 3. 105. So we go back to local pattern and edit it too. We're supposed to add 105. Yes. Yeah, now the spacing looks almost equal. Equidistance. We are looking for equidistance spacing. That is 556. And this this distance and this should be 556, 520. So we still have a deficit of what? 556 minus 520 divided by 3, 12. Plus 12. We add this plus 12. 567. Yeah, I think that is good now. From here to here is 497. Why? This to this. What's going on here? This and this spacing is 532. 532. And the other one is what? Between this and this is 497. 497. 532 minus 497, we get 35 divided by, we are dividing it by 4 or by 3, by 4, divided by 4, 8.75. So what are we supposed to do? We're supposed to subtract 8 minus 8.75. Was there any difference? Anyway, when you are doing the assembly, you know what to do, because you want equidistance. 514, I can foresee some difference. 514 and this is, I feel like leaving it. 514 and this is 523. 514, 523, there is a difference of 5 millimeter, of 10. 514, 523, that is 9. 9 divided by 1, 2, 3, 3, 3, 3. Spending a lot of time here. Minus 3. I feel like this is good now. If it is not good, you figure it out. 520. And between this and that, between this and this, 520. Yeah, equidistance. It will take some time there. Save. Before I go, let me evaluate from here to here. That should be 1796. 1796. Part new. Right plane again. Right plane. We are creating the hollow section for the tray slide. Diameter is 20. 20. Then we offset it by 1.2. The thickness of that hollow section should be 1.2 and should go to the reverse direction. That's good. Extrude mid plane, until we said we extrude it by what? 1796. 1796. Oh. Yes. Like that. And we save it as part number 13, BM sliding section, hollow section. Use the name that you feel it's appropriate to you. Now let us create the last part, which is the dividers. Top plane, and this should be center rectangle, and the size should be 5 millimeter, 5 millimeter, 515 plus 10, 525, 525 by 30, base flange. This 1.5, 1.2, depends with what you have. Edge flange here, that edge flange should be 20.1, and this should be 20. Okay, let me edit this sketch. Normal. I create a line here. It's okay. Another line here. That's okay. Then this line and this line, I make them construction lines. Then I dimension this. This should be 20. Even 15 is good. This and this should be, is it 5 millimeter? 5 millimeter. Is it? No, we should make this, it should be sitting, say 10 millimeter. We'll change the size if need be. This and this should be 10 millimeter. Then we trim. We are trying to notch, we are notching this angle line, not angle line per se, but channel for the dividers. Okay, normal. Then we take, is it the right plane? Right plane and the mirror entities. Mirror and the entity to mirror is that flange, edge flange that we just fixed, right? That is good. And we call this, now before we call it that, we need to give this some radius of like 3 mil. This I don't want to choose this. If I choose this, yeah, you see, I didn't want to choose that. My instincts were correct. Then I decided to think otherwise. This you can mirror one side. You can do one side and mirror the other, or you can choose all the edges that you want. In this case, I'm done. We are just removing the sharp edges, okay? That is good. Did we save it? Save part number 14 and call it BMGN separator, GN separator. Now we are done. It's just a matter of inserting those two components. Insert section and the GN separator, that and this. Then we met concentric relationship. It is between this and this. Good. Then coincident, that is this and these flashes. That is good. Then this part sits on top of the Bain Marie. That is good. We can go for distance. This should be 305. 305. That is between this face and this face. That is good. Then we can go to the right plane. I keep getting it wrong. Front plane of that and the front plane of the separator. The GN separator front plane. Yes. That is good. Now let us make a linear pattern in that direction, and we need 4 of them, and the distance should be 305 plus 30. 335. Component is this. That is good. Let us confirm, evaluate whether it is 3 or 5 between this and this. 3 or 2. 3 or 2 should be fine. We'll tell you why it is 3 or 2. Then we'll do again linear component. Linear component in which direction? This direction, the opposite direction actually. And we need how many? 5 of them at 60. 60, and we need 5. 5. And component, that's the component. The Bain Marie is done. Yeah, so this, if I were to edit it and you want exact 3 or 5, we'll edit this sketch and make this 28. Something like that. And I'm sure, I don't know, it might be a bit big. Let's see. I know why there is a difference. It is because of this bending, the bends in the separator. That should be what, 3 or 4. That is negligible. Even 3 or 2 was negligible. We still have some space. Yeah, so the Bain Marie it has taken us a lot of time, but it is done. I hope you learned something, and you can go to your workshop and fabricate a Bain Marie. And in our local market, a Bain Marie with body like this goes for what? Goes for right around, let me see, I want to check. What is the dollar? What is the dollar? What? 140 divided by, assuming that we are selling our dollar at 107, which I don't know, it's about $1,300. $1,400 there in our local market. This whole Bain Marie as it is, without the GN containers, right? Without the GN containers, it goes for that much. So thank you so much for your time. I will be pretty much around tomorrow. Hopefully we will continue with the layout. And what are we discussing tomorrow? Let's see. Tomorrow we can do the overshelf, the heated overshelves, and place them on the Bain Marie and the hot cupboard respectively. So have yourselves a wonderful day or night, depending from where you are or what time of the day you will be watching the video.